Yes, so I'm going to talk about visual presentations for operators and operator support today. And I work at Chalmers in a division called Production Systems. And we are 3 areas or 4 areas within the division. We are doing research in sustainable production, simulation and visualization of production systems. Also ergonomics and maintenance, and my research group are doing research within assembly, the assembly part of the production system and operational part, and we're also looking at automation strategies within the assembly area. So what type of automation to choose. And as we said, we had a startup of the 4th Innovation Lab at Chalmers. You can't see the text because it's white, but I will tell you. So it's a quite new lab. It has been running for almost 6 months now. So we had quite a lot of industrial partners here at our startup. And as I said, 50% of our funding is from industry, so quite a lot of applied research we're doing. And we have, in this lab, we have 4 different research areas or interests that we are doing research within. So cognitive automation, as I said, you can explain it as information support for the operators. To ease the cognitive processes for the operators. So it could be instructions, but it could also be, as Lena talked about, situational awareness, so that you know what to do when something is happening, and you know if the machines are running, depending on how much, how high physical automation level you are handling. And then we are looking at flexible meetings, and we are looking at meetings as regular morning meetings, but also meetings if an expert and novice has a meeting or a learning. Ramp up in learning and learning curves are we looking at, and also globalization, so that you could have meetings in different time and space, which I will talk about a little bit later. We are also looking at human automation interaction, so how to interact between human and different types of automation. It could be both cognitive automation and physical automation. So we are looking at collaborative robots, for example, in the physical part. And also cognitive automation, so how to interact and perceive information in the cognitive automation. And we are also looking at dynamic ICT tools. The dynamic in the tools is that the operators should have the choice to choose how to read or perceive the information. And what type of detail level the information should be presented at. And I will talk about flexible meetings, dynamic ICT tools, and cognitive automation today. So human automation interaction will not be that part, or collaborative robot I won't talk about today. And as I said, flexible meetings. The companies that we are part of our projects are getting more and more globalized. So they want to have some kind of techniques or visualization to have meetings or create some time and space flexibilities to have meetings in a more globalized way, and also to save information and data in a more structured way. So we are looking at these 4 aspects of time and space. So same place, same time. a real-time meeting. How could we store information and knowledge for from this meeting if someone else wants to know what they have said on the meeting? So we're looking at different technologies, like here, for example, they are using an iPad to take notes and pictures, and also record sounds to store in a database for later. We're also looking at same place, different time. It's like different shifts, for example. Today, industry are using quite a lot of whiteboards, as Helena talked about. We have different types of smart boards that we are using, so that you can write and you can link to different documents and so on. And you can also save it, and you can change the information within the documents between shifts. You can also send messages within the board. And you can also store it much easier than if you write something on a whiteboard, because then you have to put the information in another information system again. So you have here you only write it once and you can store it. Different place, same time. That is guidance, remote guidance. I will talk more about that later. We also have a demo in our monter outside if you want to test this. So we'll talk about that later. And then we have a different place, different time, which is if you are an expert and you can't be present, we are looking at how the operator could have the best information in a structured way, so that the operators get the same information each time. So we have done quite a lot of movies with audios, text, and linked it to QR codes and so on the machines. So it's easy to find the information, because that's also a problem in industry. If it takes too long time to find information, the operators don't use the information. So cost-benefit issue. If it costs more than they think it will be used, then they don't use it. And we are not only looking at the technology or the information system, we are also looking at the organization systems. So how is the structure in the company? Is it a flat organization? Is it a lot of hierarchies? Who are present at the meetings? Who wants to have the information after the meetings? What activities are we going to do at the meetings? How could we go from tacit knowledge to shared knowledge? That's also one of the aspects that we are looking at in this project. So quite a lot of different questions regarding time and room flexibility regarding meetings. And we are also looking at different ways of presenting or visualizing assembly instructions. Today at industry, if you are lucky, they have assembly instructions at the assembly line today. In 80% of the cases, they don't. So we are looking at how to increase the usage of information and instructions, because we see that actually it's not the novice operators that are doing the most quality, the mistakes. It's the experts, because they use the products as information, and if it's something that is customized on the products, it often gets wrong. So quite a lot of the quality issues is done by experts. So we wanted to have some information system that alerts the operator if something is changed due to the ordinary product. And we also want to visualize different types of information instructions to see if it matters what type you have, and also due to quality, cycle time, and those kind of things. So we call it information carrier and information content. So here you see different carriers. So we have one picture over the most difficult tasks that have most quality issues on the right. And then we have a movie that the operators could play and play again and pause and so on. And then we have the remote guidance that we have out here and in our monitor, that the operators uses glasses and a camera, and then the expert is guiding the operator to show how to assemble. And then when they have done it the first and second time, the operators could just remove the glasses and point the camera towards the assembly area. And then the expert could still see what the operators are doing and guide him through phone. And we have seen that the remote guidance, it's quite hard because it takes some time to get used to the technology. These glasses are quite good, and there are some glasses that you get really seasick in, so you can't use it for like more than 5 minutes. But these are quite good, and they are quite good that you can take them off when you don't need them. Movies we have seen are quite good also due to quality. Often the operators only look at it 1 or 2 times, and then they pause at the same picture that we have in the first, the hardest thing. So they actually use it in the same way that the picture is used. So you could use the picture instead. But in the learning sense, the movie is better because they watch it 1 or 2 times before they start to assemble to see the different tasks, and then they pause on that picture. And this is how it could look like in industry. So we have quite advanced instructions from some industries. So the first one is from Saab Aeronautics, their Gripen E project, a new airplane. When they have transformed all their instructions from 2D instructions, big A0 blueprints, to 3D instructions, where the operators actually could rotate, and they can take away different parts that they don't assemble in this task. And they also have pictures and text on the side to show them how to assemble. And that's probably the most advanced instructions in the world right now. So, and they are developing it together with Boeing in US. And then we have one prototype that we have developed together with SKF, which is more about maintenance and checklists for maintenance morning round. And it's dynamic, so the operators could actually choose, or the manager choose how long and what machines that the operator should take that morning. They used to have Excel sheets, which was like 3 to 5 pages. And since it wasn't dynamic, it was on paper, the operators have to check every step each morning, so it takes quite a lot of time. So here they can prioritize the most important machines with the highest quality issues that morning. It takes, they save quite a lot of time each morning. And then they also have a blog So they can blog different text messages to the manager that gets the message, and then they take it to the meeting with the other Fabric managers. So that also saves time because they don't meet physically like they did before. They just blog a message, and then the boss blogs back, okay, I have seen your message, thank you. I will bring that up on the meeting. So it saves quite a lot of time to have it digitalized and dynamic. And now you can't even see it, but this is actually how it looks at Volvo trucks. They only have text-based assembly instructions or instructions. It's basically a list of components that should be assembled. So you don't actually show how to assemble, what kind of tool should you use, how should you do it. It's just the components that you should assemble. So you need to be quite experienced to work at this line. And this is another example of the same instructions, but a little bit more advanced. It's still text-based, but the operators could actually choose if they want to see more information, so they can click it and then a picture appears on the screen. But it's not done automatically, and as I said, if it costs more than the operators gain, they don't use it. So it's not used that often. They usually think that they know how to do it. But here they have some help of the different tools that they should use, and also this blue dot indicates that it's something that is different due to the original component or product. As I said, we are using augmented reality and glasses from XM Reality. This is a consulted company called Gartner that are looking at emerging technologies each year. And we started doing experience with iPod Touch in 2007 because iPhone didn't exist then. So the technology has evolved quite a lot in the last 5-10 years. And here you can also see the involvement of augmented reality and wearables. And augmented reality is soon to be not an emerging technology, or it's actually used not only in labs but in industrial application. And we see a lot of different things out here as an example. And you can visit us in our monter. It's right outside here to assemble some Lego to test this technology. Thank you for me.
Thank you, Åsa. Okay, I'm going to send you directly to the meet and greet room.
Yes.
Because we are running a little bit late. I think there are probably some questions, but we will have to meet Åsa in the meet and greet room because we have a coffee break and the exhibition to look at. So thank you very much for this presentation.
Thank you.
Åsa.